everyone, my name is Savannah and I'm currently a junior here at the University of Florida studying for the MCAT this semester. Today, I wanted to present some of my tips and tricks while tackling the MCAT, specifically the physics section. The physics section of the MCAT is the first section, which consists of both physics and chemistry problems, and it is out of 132 points, 59 questions, and you get a total of 95 minutes to complete this section. This sounds like a lot of time, but when you do the math, it's about 1.5 minutes per question, and without a calculator, formulas, or any sort of help, this can be very challenging. So today, I want to discuss some of my tricks towards handling these questions, both with estimation and mathematical tricks, in order to be successful in this section of the MCAT. The first thing that I want to go over today is how to estimate numbers in the physics section without the use of a calculator. So the MCAT questions are going to have challenging numbers, but you are not expected to spend all the time doing long division and complicated multiplication problems. The exam makers are going to carefully craft these questions so that there are other options to solve them without spending all of this time. Overall, I have a few tips to tackle this section of the MCAT. Always look at your answer choices first in order to determine how specific your estimation needs to be. Different questions will have numbers that are either closer together, varying by decimal points, or further apart, varying by even powers of 10 sometimes. So it's important to look at this first. And lastly, this is what I consider the most important advice. You're not solving for an exact answer in this section of the MCAT. You're instead choosing the right answer based on the 4 that the test makers give you. The first trick that I'm going to go over is in regards to multiplication while you are estimating numbers on the MCAT. So first off, rounding numbers to 1 decimal point while multiplying should be sufficient for most questions on the MCAT. However, you should still always check how close your 4 answer choices are in relation to each other on each question, because this can differ significantly in how you're going to approach the question. For example, if each answer choice is off by slightly different decimal points, you might want to be more specific in your rounding. But if each answer choice is off by powers of 10, you might need to be less specific and therefore could spend less time on the math part of the problem. And it is also important to note whether your rounded number is smaller or larger than the original, because you can use this information in order to eliminate certain answer choices or be more aware of what range your real answer is going to fall. And another tip that I have is rounding 1 number up and 1 number down when multiplying in order to get a more accurate answer estimation. And this is very specific to the problem type itself, but this can be a helpful trick. And we're going to start by doing an example together. So although you will never be presented with a question like this where you're multiplying 2 decimals on the real MCAT, it is important to go through because this could be a small step of a longer question in the physics section. So we're going to start by multiplying these 2 numbers. So my first step in doing this is changing both numbers to just have 1 decimal point. So we're going to multiply 5.4 times 2.3. And when I'm multiplying 2 numbers with decimals, I like to convert 1 number into a whole number to start and then multiply its decimal component later on and then add these pieces together. I just think it's a little bit easier to do in my head without a calculator. So we're going to start with 5.4 times 2.0. And I like to move the decimal points in order to make the multiplication easier, and then I will move them back at the end. So I'm going to move the decimal point in 5.4 1 to the right, so we'll have 54 times 2, and 4 times 2 is 8, 5 times 2 is 10, so we have 108, and then we'll move that decimal point back 1 to the left. So we have 10.8. And now we have the 0.3 left of the 2.3 decimal. So we'll do 5.4 times 0.3. And we can move the decimal point in both 5.4 and 0.3 one to the right to make this easier. So we'll have 54 times 3. And 4 times 3 is 12, carry that 1. 5 times 3 is 15, plus 1 is 16. And then because we moved the decimal point twice, we'll move it twice back to the left. So we'll have 1.62. And then we're just going to add the 10.8 plus 1.62 together. So we'll get 2, 8 plus 6 is 14, carry that 1 at that decimal point, and we'll have 2 and then 1. So we get an estimated value of 12.42, which is very close to the real answer of 12.579. And as you can see on the MCAT, this falls within just a few decimal points. So when you were given 4 answer choices, this should be close enough where you are easily able to identify the correct answer. As previously mentioned, when we are given answer choices on the MCAT with numbers that are either further apart or closer together, we may want to adjust how many decimal points we are rounding to. So specifically for this example, we can see that each answer choice is further apart from each other, varying by almost 1 whole number each. So based on this, we do not have to round as specifically, and I'm actually going to round one number to 1 decimal point and then the other number to a whole number. So in this case, I'm going to round the 0.912 to 0.9. And then I'm going to round the 11.2 to just 11. And then now this becomes a very simple multiplication problem where we get an answer of 9.9. And now, looking at our answer choices, we may be between B and C as they are both very close to the 9.9. But using another trick that I already discussed, we know that we rounded both numbers down when we solved for the 0.9 times 11. Because of this, we know that our real answer is actually going to be greater than the answer that we just solved for. So therefore, we can eliminate the 9.7 as it is too small to be the real answer. And the next closest answer that we see is B. Therefore, on a question like this on the MCAT, we know that 10.2 is the correct number if you were to multiply these two with a calculator. Now I'm going to discuss some tricks that I have when dealing with division in the physics section of the MCAT. So first, unlike the multiplication estimations, you cannot adjust both of your answers in opposite directions. This will just cause you to get an answer further from the real answer that you would get with a calculator. Instead, you should proportionally round the numbers in the same direction so that the ratio between the two numbers that you're dividing stays as close as possible. So I'm going to start with an example of this. If you are given 11.851 divided by 3.525 and the answer choices below that are relatively further apart from each other, we can round both of these numbers to whole numbers to start. So 11.851, I would round this to 12. And then 3.525, you might be torn between rounding this up or down, but in this case, because we rounded the 11.851 up to 12, you also need to round the 3.525 up to 4. So then you get a rough estimate of 3. But I'm also going to show you what would happen if you rounded them in opposite directions. Because based on this, we know that our correct answer is C, as it is the closest. But let's say we did 12 divided by 3, where we rounded the 3.525 down opposite of the 11.851 that was rounded up. Then we get a rough estimation of 4. So now we might be torn between A and C, when in reality the answer is much closer to C. So it is just important to keep in mind that you need to round both numbers in the same direction when you're dealing with division. Now we are going to apply the estimation tricks with both multiplication and division into a problem that could be presented on a real MCAT within the physics section. So to start off, I'm going to read through this question. A pipe of diameter 1,868 millimeters filled with water flowing at a speed of 0.6957 meters per second increases in size to a diameter of 3,130 millimeters. Find the new speed at the greater pipe size and round your answer to 3 decimal places. Another important thing to note about the physics questions on the MCAT is that you're not given any formulas, so these are things that you need to memorize and be familiar with. So reading through this question, I can see that I'm given diameter of different pipe sizes, which could be applicable to area, and I'm given the speed at which the water is flowing. So knowing this, I'm going to apply the flow rate formula to this question. So I'll start by writing this out. Q equals A1 times V1, which equals A2, V2. So now I'm going to break down the different components of this formula. So A1, V1 equals, we are given the diameter and the speed for this first section. So we know that the area of a circle is pi r squared. So we can rewrite this as pi times the diameter of the first pipe divided by 2 squared times the first velocity or speed. And now we're going to do the same for the second part. A2 V2 equals pi times d2 over 2, and this value gets squared, times V2. So now we have each component, and we know that these are all equal to each other. So now we're going to apply what's given, and we're going to solve for the second speed. So first off, there's some things that can be simplified in order to make your life easier, especially without a calculator. Let me just rewrite this here. And we have pi times d2 squared over 4 times v2. So we can cancel out the pi, and we can also cancel out the 4. So now we do not need to find the radius. We can actually just use the diameters given in this question. And we're going to solve for v2. So v2 equals, we have d1 squared times v1 divided by d2 squared. So now we can plug in the numbers given and do the math estimation part of this question. So now that we have the algebraic solution to this problem, I'm going to write this out again. We have v2 equals d1 squared times b1 over d2 squared. And now we can plug in the numbers given in this problem. So d1 equals 1,868 millimeters, but we need to convert this to meters as this is the standard units. And this can be done just by simply moving the decimal place 3 to the left. So now we have 1.868 squared and 0.6957 divided by, and we will do the same for this diameter. There's 3 places to the left, 3.130 squared. So now, given these numbers, this would be very difficult and time consuming since we don't have a calculator, so we're going to apply some of the estimation tricks we previously went over to this question to solve. So I'm going to start by rounding 1.868 to 1.9. And then I'm going to round 0.6957 to 0.7. And then we will round 3.130 to just 3 because it's pretty close. And now we're still going to have to do a little bit of math for this question because when we look at the answer choices, they are somewhat close to each other. So we're going to multiply 1.9 times 1.9, and I'm going to do this in the corner here. And I'm going to move the decimal point 1 to the right for each 1.9 in order to multiply 19 times 19, and then I will move them back after. So 9 times 9 is 81, and then 9 times 1 is 9 plus 8, 17. Add that 0, and then 1 times 9 is 9, and then 1 times 1 is 1. We have 1, 7 plus 9 is 16, carry that 1. We have 3, 61, and then we're going to move the decimal point back 2 to the left. So we have 3.61. Now we're going to plug in that value. So 3.61 times 0.7 divided by 3 squared is 9. And now we're going to multiply 3.61 times 0.7. And I'm actually going to round the 3.61 to 3.6. And we're going to do this right down here. I'm going to apply the same trick that I applied where I moved the decimal point here. So I moved the decimal point in 3.6, 1 to the right, and then 0.7 also 1 to the right. So 6 times 7 is 42. 7 times 3 is 21, plus 4 is 25. And then we'll move that decimal point. So we have 2.52. Now, looking at this may seem tricky, but I'm going to use prior knowledge that 9 divides into 27 3 times in order to solve this. So we know that dividing 2.7 then divided by 9 is going to equal 0.3. So if we have a smaller number divided by 9, we know that this is going to be slightly less than 0.3. So looking at our answer choices, we can eliminate A, B, and C. And we know that our only possible answer is going to be D, 0.248 meters per second.
Now, we're going to talk about how to approach square roots on the physics questions that you will encounter on the MCAT, specifically how to do this without a calculator. So square roots can come up in lots of different question types on the MCAT. For example, you might see this with vector magnitude, conservation of energy questions, kinematics questions, and even force questions involving centripetal acceleration, for example. So to go through these, first, let's say that you have to solve a question involving the addition of two vectors. So let's start with vector A, and then we have vector B. And let's say that you are finding the sum, which would be vector C. We would do this using Pythagorean's theorem, where C equals the square root of A squared plus B squared. So in this case, you would have to solve for a square root. Second, if we're solving a question involving conservation of energy, it's highly likely that you're going to need to use kinetic energy. And we know that kinetic energy equals 1/2 times mass times velocity squared. And let's say you need to solve for velocity. In this case, you would have to square root in order to find velocity. Now, if you're approached with a kinematics question, specifically using the equation final velocity squared equals initial velocity squared plus 2 times acceleration times delta x, and you're solving for either the final velocity or the initial velocity, you're going to have to find the square root. For our last example, we know that centripetal acceleration equals velocity squared over the radius, and in the case of using this with force, we know that the sum of forces equals mass times acceleration. And if we're using centripetal acceleration, we can plug this value in here. So then we have force equals mass times velocity squared over r. And if we're solving for velocity, we know that we're going to have to find a square root as well. Now we're going to apply some numbers to the square root questions that we may come across on the MCAT. So first off, for perfect squares, I recommend memorizing up to 12 squared or the square root of 144. And then when you're faced with more difficult square root questions, I recommend rounding and then simplifying to solve these. And you can use a lot of the same tricks that we went over at the beginning of this video with estimation in order to do this. So to show you an example, let's look at the square root of 2.44 times 10 squared. First, I'm going to convert this to the square root of 244. Now, I'm going to use an estimation trick that we went over earlier to estimate that this is around 240. And we can do this based on our answer choices that we would see on the MCAT, but for this sake, I'm going to say that our answers are far enough apart that we can use this estimation. So now we're going to bring back the tree that we used in elementary school in order to break down square roots. So first of all, 240 will divide into 24 and 10. And now we know that 5 times 2 equals 10. 6 times 4 equals 24. 2 times 2 equals 4. And 3 times 2 equals 6. Now looking at this, we have 4 2's. So this means that we have 2 pairs of 2. So 2 times 2 equals 4. And we'll put this on the outside of our square root. And now we're left with 5 and 3, and 5 times 3 equals 15. Now, looking at this square root, it's going to be much easier to make a more accurate estimation. We know that 15 is pretty close to 16, and 16 is a perfect square with a value of 4. So I'm going to estimate this as 4 times 4. And we know that this is also going to come out to 16. And because 15 is less than 16, we know that our answer is going to be slightly less than 16, but it's going to be around this number. And our real answer would actually be 15.49. So as you can see, this is a pretty close estimation. Now we're going to apply what we went over regarding square roots to a question that you could encounter on the MCAT. Specifically, this is a conservation of energy example. So here we have a small child who decides to go sledding down a hill with a height of 10.3 meters. What is the speed of the child and their sled as they reach the bottom of the hill? Give your answer to 2 decimal places. So to start off, I'm going to draw this hill so we get a better visual of this problem. So here's our hill, and we know that this hill is 10.3 meters tall. And we know that the child is going to start at the top of the hill on their sled, and then they're going to sled down to the bottom. Based on this, we can apply the law of conservation of energy because we know that the initial energy is going to equal the final energy. And looking at this picture, we know that at the top of the hill, before the child starts moving, they're going to have fully potential energy, and then once they reach the bottom of the hill, they're going to have maximum kinetic energy. So to rewrite this, we know that potential energy is mass times acceleration due to gravity times height, which is going to equal our kinetic energy, which is 1/2 times mass times velocity squared. Now, looking at this, we can cancel out the mass because we know that it's the same on both sides. So now we're left with GH equals 1/2 v squared. And since we're solving for the speed of the child at the bottom of the hill, we're going to solve for v. So v equals square root of 2gh. Now we can see that we're going to have to implement what we learned regarding square roots into this question. So let's start by plugging in our values. So v equals square root of 2 times 9.8 meters over second squared, and remember this is a value that you have to memorize for the MCAT, times our height, which is given in the question as 10.3 meters. Now looking at this, because our answer choices are relatively far apart, we can actually simplify this using the estimation rules that we talked about earlier. So I'm going to change this to 2 times 10, we're going to round that 9.8, times, and then we're going to round the 10.3 down. So this is actually going to help us because we rounded one number up, one number down. It's going to make them closer together. Looking at this, you might be tempted to automatically simplify this to 10 square root 2. But if you don't know the square root of 2, be careful because your answer choices are close enough where this could be a common mistake made. Square root of 2 is 1.4 roughly, but if you think it's around 1.5, you could be tempted to pick a different answer choice. So I'm not going to use this. I'm going to simplify a little bit different. So we know that we have square root of 200, and we're going to make our tree. So we have 20 and 10, 5 and 4, and 5 and 2. Looking at this, we know that 5 is seen twice, so we're going to pull that out. So we're going to have 5 square root, and 4 times 2 equals 8. So now we know that square root of 9, which is close to 8, is 3. So we know that square root of 8 is going to be roughly 3, but it's going to be a little bit less. So we're going to have 5 times 3. And this is going to equal 15. But looking at our answer choices, we might not be sure between A and B, but what I will say is that looking back at that 8, we know that we rounded up when we found the square root. So therefore, we know that our answer has to be slightly less than 15 in order to account for this. So we know that our answer choice is going to be A, 14.21 meters per second. Now we're going to move on to our next topic that I'm going to cover today, and this is going to be about trigonometry on the MCAT, and specifically using a left-hand rule trick in order to solve trigonometry questions that you may encounter. So sometimes it can be hard to find the sign of a certain degrees without a calculator, but this trick should hopefully make this a little bit easier. So using your left hand, as you can see, I have a left hand on the screen here. We can break down each of our fingers into a different degree. So our pinky, for example, is going to be 0 degrees. And then this finger will be 30 degrees. This finger, our middle finger, will be 45 degrees. This one will be 60. And then our thumb is going to be 90 degrees. So based on this, we can actually find the sine and cosine of each of these values. So first, let's start with 30 degrees. If we put this finger down, I'll put my hand up to show, like this, we can look at the top part of our hand as cosine and the bottom part as sine. So let's say that we want to find cosine of 30 degrees. So we're going to count our fingers, 1, 2, 3, square root this. And then this is always going to be over 2 for all of these. Similarly, if we're going to find sine of 30 degrees, we're just going to do the opposite. So we're still putting this finger down, and now instead of looking at the top 3 fingers, we're going to look down at our pinky. So we have 1 finger here, and this is always going to be square root of that amount of fingers divided by 2. So square root of 1 is 1. So we have 1/2. And this applies to every finger. We'll do 45 degrees and 60 degrees quickly just to demonstrate this. So 45 degrees, looking at our hand, we know that both sine and cosine are going to be square root of 2, 1, 2, over 2, and then square root of 2 over 2. So cosine of 45 degrees, and then sine of 45 degrees. And then with 60 degrees, we're going to put this finger down. We have cosine equals 1/2, and then sine equals square root of 3 over 2. Cosine of 60 degrees equals 1/2, and then sine 60 degrees equals square root of 3 over 2. And although this applies to the first quadrant on a graph, we can apply this to others based on the negative and positive signs of your x and y values. Now we're going to apply what we went over regarding the left-hand rule with trigonometry to a question that you could see on the MCAT, specifically a 2D kinematics question. So here we have a person who kicks a ball from the ground at an angle of 60 degrees off the horizontal at a speed of 10 meters per second. How long does it take in seconds for the ball to reach the ground again? Express your answer to 2 significant figures. So first, for every kinematics question, I always like to draw a picture first. So we have a person here. They're going to kick the ball from the ground at an angle of 60 degrees off the horizontal and a speed of 10 meters per second. So now, looking at this, we know that we're going to have to break down the speed into the velocity, x and y components in order to solve using the kinematics equations. So let's start by doing this. I like to draw a chart, breaking these up. And first, let's find the velocity in the x direction. So in order to do this, we'll have 10 times cosine 60 degrees. And for the y direction, we have 10 sine 60 degrees. So now let's use our left-hand rule we just went over. So looking at our left hand, 60 degrees is going to be our pointer finger, so we'll put that finger down. And let's start with x. So we know that cosine is going to be above the finger we put down, so we'll have square root of 1, which is just 1, divided by 2. Every value is always divided by 2. So cosine of 60 equals 1/2. So we have 10 times 1/2 equals 5 meters per second. Now let's find the velocity in the y direction. So once again, this finger goes down for 60 degrees. Now we're looking at the fingers underneath. So we have 1, 2, 3. Remember, square root, so square root of 3 divided by 2. So we have 10 times square root of 3 divided by 2. And for the sake of estimation, we're going to round square root of 3 to square root of 4 since it is a perfect square. And this gives us a value of 2, and 2 divided by 2 equals 1 times 10 equals 10. And it's important to keep in mind that since we rounded up for square root of 3 to square root of 4, our real value for the velocity in the y direction is going to be less than 10, which is going to come in handy at the end when we make our final answer choice. So now looking at this, let's go back to look at what the question asked us. So we're trying to find the time in seconds. Knowing this and knowing what we were given in the equation, we're going to use a kinematics equation to solve. Now, going back to look at what we were asked in the question, it is clear that we're solving for time. So based on my knowledge of kinematics equations and what we're given in this question, I'm going to use the kinematics equation final velocity equals initial velocity plus acceleration times time. And remember, for a question like this, we're going to solve either in the y direction or the x direction. Looking at what we have here, we have the velocity in the y direction. We also know that halfway between this trajectory, our velocity in the y direction equals 0. And we know that our acceleration in the y direction is just our acceleration due to gravity, which equals negative 9.8 meters per second squared. So because of this, I'm going to solve for time using y components. So now let's rearrange this equation to solve for time. Time equals final velocity minus initial velocity divided by acceleration. So now we can go ahead and plug in some values. Time equals, we know that our final velocity we will treat as this middle point here. And then our initial velocity in the y direction is going to be 10 divided by negative 9.8 meters per second squared. This gives us a value of roughly 1. If we round that negative 9.8 up to 10, we're going to have around 1 seconds. And it's important to note for this question, we did look at our final velocity in the y direction as the middle point of this trajectory. This doesn't account for the whole time that the ball was in the air till it was back in the ground. So we need to multiply our time by 2 because this would account for the whole time that the ball was traveling. So we have 1 second times 2 equals 2 seconds. And now looking at our answer choices, we might be between C and D, but looking back at our estimations that I said to note at the beginning, we remember that 10 meters per second was an overestimation because we rounded square root of 3 up to square root of 4. So therefore, we know that our answer cannot be greater than 2. So based on this, I'm going to guess C, 1.8 meters per second, which is the correct answer. That is the end of my video. Thank you for watching, and I hope that some of these tricks that you learned throughout will help you on your MCAT.